So chapter 5, probability distribution. 5.1, random variable. Okay, so first of all, to understand what is random variable, normally if you see random variable is represented by using x. So that means something that you can change, so it's variable, a number that you can change. Okay, so we have two kind of random variable, discrete random variable and continuous random variable. So you can see in the note, the values of the discrete random variables are obtained by counting and take on whole number values only. So example, counting number of people, let's say number of people attending the course, for example. Okay, so number of people is discrete because you have to count to get the number of people, and they can only take whole number values like 1 people, 2 people, 3 people, and so on. So it cannot take number other than whole number, so like they cannot take 3.8 people, cannot. Okay, so we cannot take decimal number for the number of people. Okay, it's not reasonable. Now let's see another example. Let's say, okay, so discrete, another example, discrete random variable, number of days of raining in a week. Okay, so in a days, how many days are raining, so you have to count. Okay, so of course raining doesn't mean 24-hour raining. As long as there is raining in any particular duration, then it is counted as a rainy days. Okay, so because of that, so we can just count the number of days which are raining. Okay, so and then they can only take whole number also, like there are 3 days raining in 1 week. Okay, there are 2 days raining in 1 week. Okay, so now let's compare with continuous random variable. Okay, number 2, the values of the continuous random variable are obtained by measuring. So you see, measuring, this is counting, and now this is measuring, and take on real number values. Real number values include decimal, include fractions. So for example, let's say, okay, I use different color for continuous. Okay, so let's say the height of students in class 5A, for example. The height of students, so you want to find out the height, you have to measure their height. You cannot count their height, you have to measure their height. And the height can take any real number values, for example, like 162.3 cm. It takes decimal, you see, it's not taking whole number only. It can take decimal. It can also take whole number like 168 cm. That is whole number, so whole number is accepted. Number in decimal is also accepted, and you are measuring it. So that is continuous. Okay. Another example, let's say you want to find out the weight of chicken, in the market, for example. So then you have to measure the weight by using weighing machine, and then it can take decimal number. It's not just taking whole number values only. So that is the difference. Okay? Two main difference: counting versus measuring, and then whole number values versus real number values. So these are the two main difference between discrete and continuous. Okay, now let's see part A. State the random variable and determine whether it is a discrete random or continuous random variable. Number of children in a family. So you want to know the number of children, you just go and count, okay, 1, 2, 3, like that, so you have to count. So that is discrete random variable. Okay, so discrete random variable. Okay, then B, length of leaf on a mango tree. So you want to find out the length, you need to take ruler or measuring tape to measure. So it's measuring, so it's continuous random variable. Continuous random variable. Okay, I write in short. Okay, now let's move on. B. State the possible values of each of the following random variables x. Okay, so example A. Total score obtained when two fair dice are rolled simultaneously. Total score. Okay, you are rolling two fair dice. Okay, so we write it down here. The possible values. Okay, so x can take, let's say put in set. You see, the values of a random variable x is x. Set x contains all the possible values of x. Set notation is used to represent a set x. Okay, so we use set notation, something like this. Okay, so when you throw or when you roll two fair dice, so you may get 1 and 1 as the smallest possible score. So 1 and 1 you total out, you get 2. You may get 3, 4, 5 until 12, 6 and 6 for each dice. So you will get maximum of 12 as your total score. 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we look at B. The masses of the Form 5 students are between 45 kg and 65 kg. Okay, so then we put it in this way.
Teacher,
Yeah.
why the total score no number 1?
Because you're rolling two fair dice. Each fair dice must show minimum of 1, so 1 plus 1 you get 2. We don't have 1 plus 0, the dice never shows 0. Never shows 0. Okay. By the way, do you know what is dice here?
Yes.
Okay, so because it never shows 0, so that's why we don't have, it's not possible to get a total score of 1, because we can't have a case where one die show 1, another die shows 0. It doesn't have this kind of scenario. Okay, so because of that. Okay, now for B, I write it this way. So from here you can see something. What we can see is A, right? It's obviously a discrete random variable that take whole number values. We just write down one by one. For B, you can see there are continuous random variable. It takes decimal. Writing down one by one is not possible because there are too many numbers to write. Like all the integer from 45 to 65, as well as those decimal, unlimited numbers of decimal like 45.3, 45.25, so all kind of decimals are accepted, so that's why we write in interval. Okay, so let's move on. Okay, so after that we have part C. Determine each of the following probability distribution using a tree diagram. Then tabulate all the probabilities in a table. Okay, so they say using a tree diagram. So we see the example. Experiment: 2 fair coins are tossed simultaneously. The random variable x is the number of heads obtained. Okay, so we draw a tree diagram in this way. So when you toss the coins, you may get head or tail. This is the first coin. So then you toss the coin again for the second round. So this is the second coin. So you may get head, tail, head, tail. Okay. So in the case where you get like here, the first one, head followed by head, so the number of heads obtained is 2. Okay, so I just write here 2. For the second case, you get head followed by tail, so this is 1 head. X represents the number of head, by the way. 1 tail followed by 1 head, so X is 1. Finally, tails and tails, so 0. Okay, 0. Okay, now that is the values of X. So after you write down the values of X, now we have to put everything in probabilities. So how we count probability? So you see, it is a fair coin. The probability to get heads is half. The probability to get tails is also half. Even for the second coin, it will be the same probability because it is a fair coin. Okay. Now, in order to get the probability for 2, we take 1/2 times 1/2. So 1/2 times 1/2, so you will get 1/4. 1/4. Okay, so for this case, 1/2 times 1/2, you get 1/4. 1/2 times 1/2. You see, all of them have the same way of calculation of the probability. Yeah, that's 1/4. Okay, now we put them in a table. So when I say a table, right, so we build a table with 2 rows. The first row is the X. The second row is the probability of X. So we can only take 0, 1 and 2 only. Probability for 0, right, so it is this case. Probability of 0. So the last case, 1/4. So this is 1/4. Probability of 1, right, is this and this. So which is 1/4 plus 1/4. So we know 1/4 plus 1/4 is 1/2. Then probability for 2 is here, which is 1/4. Okay, so we get the tree diagram, then we get the table. So we have done for this. Now let's move on. So we have a similar question here, and then you have to draw tree diagram followed by table. So let's move on first. Okay, now we look at part D. Plot the graph for each of the following probability distribution in part C. So you can see our table just now. It's the same table from the part C example. So you know the two fair coins where the number of heads, it can be 0 heads, 1 heads or 2 heads. The probability are here. So how we plot the graph? So we put it on a graph paper. When I say plot, And then for 0, you have to draw to the height of 1 over 4. So 1 over 4, let's set the height here. 1 over 4. For 1, you see r is 1. I'm using x by the way. I use capital X equal to small x. So if that's the case right here, you have to use small x. Okay, so that's for your information. If I use x, then the x-axis I label x. If you follow this book, they use r, then the x-axis, the horizontal axis, you use r. Okay, so I put like this as your remark. R or x depends on how you set your table just now. Okay, now you can see after they mark down the probability 1 over 4, 1 over 2 and 1 over 4. So you can see 1 over 4, 1 over 2, 1 over 4. Then you draw vertical line. So after you drew the vertical line, so what happened is this represent the discrete probability distribution. Only integer or only whole number has values. Like 0, we have probabilities. 1, we have probabilities. 2, we have probabilities. Like 2.5, nothing. No probability because this is discrete. Okay, so that is how we draw the graph for a discrete. They are just vertical line that where the height represent the probabilities. Okay, so let's move on. Okay, now we see 5.2 binomial distribution. Okay, binomial distribution. So let's see the question here. Solve each of the following. Okay, let's see the question first. A fair dice is rolled 8 times. Find the probability that score 6 appear exactly twice. Okay, so how to solve? Okay, now I give you an example first. Or formula at least. You need some formula. Okay, so you need some formula for this case. Okay, so binomial distribution, right? First, you need to know it is a discrete distributions. Okay, the second thing is you need to know it has two outcomes. So from the word bi, for example, bicycle means 2 views, so binomial means 2 outcomes. So what is meant by 2 outcomes? You see, for example, find the probability that score 6 appear exactly twice. Score 6 appears. The opposite of this is score 6 doesn't appear. So these are the 2 outcomes. Score 6 appear, score 6 doesn't appear. Okay, so 2 outcomes where they are normally opposite. One is yes, another one is no. So in general, we call it, we have the case of success and the case of failure. Success is like whatever the questions are looking for, then that is called success. Okay, so for example, like find the probability that score 6 appears. So score 6 appears is counted as success. Failure is the opposite. Score 6 doesn't appear, and then that is failure. So we have success and failure. The probability of success, we put it as P. The probability of failure, we put it as Q, where Q is 1 minus P. 1 minus P. Let's say, for example, right, we are talking about this. Success, like what I said, score 6 appear. Score 6 appear, that is success. So what is the probability? You roll a dice, so because the dice is a fair dice, so the probability to get each score is 1 over 6. Okay, it's 1 over 6. To get 1 is 1 over 6, to get 2 is 1 over 6, to get 3 is 1 over 6, and all the way to 6. To get score 6, the probability is 1 over 6. Since the question is asking score 6, right? So P is 1 over 6. P is 1 over 6. Then how to find Q? Q is 1 over P. Sorry, Q is 1 minus P. So you want to find Q, 1 minus P. 1 minus P is 1 minus 1 over 6, which is 5 over 6. Okay, now what else? Okay, so we also need to know n also. N is the number of trials or the number of repetition. Okay, so there are many ways to represent this n, so we need to know the n also. Okay, so number of trials or number of repetition, how many times you do the same things. Okay, so for this case, a fair dice is rolled 8 times. You are repeat doing the same thing for 8 times. So because of that, the number of trials, the number of repetition is 8. N is 8. Okay, N is 8. Okay, now after that, how to find probability formula? Okay, so for binomial, you have n, you have p, you also have q. You have npq now. To find the probability, the formula is probability of x equal to r equal to ncr p power r q to the power of n minus r. Okay, so this is the formula for the probability under binomial distribution. Okay, so now let's come back to this question. So you have n, you have p, you have q. You can use this formula now. They are asking us to find the probability that score 6 appears exactly twice. Score 6 appear exactly twice. So that means px equal to 2. Okay, twice, because of the twice. So we put px equal to 2. So the n is 8, followed by c. You look at the formula at the same time. The r is 2. And then multiply with p to the power of r, 1 over 6 to the power of 2. Q to the power of n minus r, which is 8 minus 2. Okay, then after that, we just press calculator. Okay, we press everything, then you will get the probability. Okay, so for example, 8c2 times 1 over 6 square times 5 over 6 to the power of 6. So you get 0.260. So that is how we get a probability. Okay, so let's see it one more time because it's kind of complicated, right? Okay, now let's say I do question 4. Okay, let's see it again. Question 4. The probability that a dog finishes a task successfully is 4 over 5. So I'm going to call this P. Success. P. Okay, 4 over 5. That means the dog can do it. Probability 4 over 5. So Q is failure, right? That means the dog cannot do it. If the dog cannot do it, then you want to find the probability, you just use 1 minus P. 1 minus 4 over 5, which is 1 over 5. Okay, now let's continue. In 8 attempts, number of repetition or number of trials, they are doing it for 8 times. So n equal to 8. So we need to know NPQ basically. When you know NPQ, then you can continue with the probability formula. In 8 attempts, find the probability that the dog succeeds in 6 attempts. Probability of x equal to 6. So because the question is asking for the probability of 6, so we write like this, px equal to 6. Okay, then we use formula NCR p to the power of r, q to the power of n minus r. That means 8 minus 6. Okay, then we just check with calculator. So 8c6, 4 over 5 to the power of 6, and then 1 over 5 to the power of 2. So we get 0.2936. Okay. So that's how we do it. Now let's move on. List the probability for every values of x and plot the graph for each binomial distribution. So you can see the graph is again vertical line because they are basically discrete. You see I wrote on top already. Binomial is discrete. You know the graph of discrete is vertical line like what we discussed just now. Okay, now let's see how we get the line. So first you need to list the probability. Okay, let's see first. A fair dice is rolled 4 times. So this is n. This is n. N equal to 4 because this is the number of repetition. How many times you repeat doing the same thing. So you are doing it for 4 times. X is the number of times of getting a score of more than 4. More than 4. Okay, so if they talk about this, more than 4, that is success. Success is probability for score more than 4. Okay, so more than 4 means 5 and 6, 5 and 6. So 2 outcomes over a total of 6 outcomes. When you roll a dice, you will get 1, 2, 3, 4, 5, 6. So that's why 2 outcomes over 6 outcomes. So 1 over 3. So probability of failure. Failure basically means probability of getting score less than or equal to 5. Less than or equal to 4. So the probability is 1 minus p, which is 2 over 3. 2 over 3. Okay, so now we have n, we have p, we have q. So how to list the probability? We just keep using the formula. You see our formula again. This is the formula. So you have to use this formula again and again to find the probability of x equal to 0, probability of x equal to 1, 2, 3, and 4. Okay, so maybe you feel like, wow, too many things to do. Okay, too many things to do. We have to use the formula for so many times, for 5 times. Okay, so that is a shortcut. Use calculator. Okay, let's see how to use calculator. Okay, so it depends on what calculator you are using, but the way to press it is more or less the same. Okay, so first we need to know the formula of probability. Px equal to r, ncr, p to the power of r, q to the power n minus r. This is the formula. Okay, so to press calculator, first we need to know we have to count many probability. We have to count probability of x equal to 0, probability of x equal to 1, probability of x equal to 2, probability of x equal to 3, probability of x equal to 4. Should we count probability of x equal to 5 or not? No. Okay. Until when? Until what value should we stop? Until the n. So if the n is 4, so just count from 0 all the way to 4. If n is 5, count all the way from 0 to 5. Okay. So if n is 10, maybe you feel like, oh, headache. I have to count 0 to 10, but we are using calculator. How to use calculator? Okay, so we have to key in like this. Okay, you key in. You have to key in your calculator in this way. So first, our n is 4, right? So 4c x. Okay, so 4, how to press C? For my calculator, shift divide. Shift divide. So shift divide, then you can see the C on the calculator screen. C, yeah. Then how to press X for my calculator? It is alpha close bracket. Alpha close bracket. You can see there is a red color C on that button. So after you press, you will see on the calculator 4cx. 4cx multiply. So we put multiply. Okay, so my calculator will show something like this. The x they put in this way. Then after that I say multiply, right? Multiply they put in this way. 4cx multiply p is 1 over 3. So bracket 1 over 3. 1 over 3. Okay. For my case, I have to use divide instead. For my calculator, 1 divided by 3. Okay. Power. Okay. So power is, for my calculator, is X and then this button. So power what? Power R, right? So R you replace by X first. Power X. So the way to press X is the same. Alpha close bracket. Okay. Then after that, you press times. So you have to press times. Okay. Make sure the times is for my calculator, right? I have to press right hand side first. So the X will be here, which is small size. When I press right hand side, then the times that it shows is the big size times. It's not the times which is same row with the formula, same row with the power X. So we don't want that. We just want the normal X, the big size X. So you press right hand side, then followed by times. Then the times will be like this. Okay, so it will be like this. Let's say I just put side by side. So followed by times, followed by bracket 2 divided by 3 to the power of, okay, let's say I don't want this symbol because my calculator don't have this symbol also. 4 minus X. 2 over 3 to the power of 4 minus X. So after you key in all this, right? After you key in all this, then you press calculate. There is a button which is called calculate. Okay. Calculate, C-A-L-C. So when you press calculate, then you can start substituting 0, 1, 2, 3, 4 into your calculator, and they will show you all the probability. So for example, after you press calculate, right, now you have to substitute 0. So you substitute 0 followed by equal. 0 equal. Okay. Then you will get 16 over 81. 16 over 81. Okay, so of course we have to show working for at least one time in order to get the marks. Let's say I show working for 0. 4C0 1 over 3 power 0 2 over 3 power 4 minus 0 equal to 16 over 81. Okay, so for 1, how? You just press calculate again. So you press calculate again. I hope you don't delete the formula. Calculate and 1 then equal. calculate 1 equal, then they will show you the probability, which is 32 over 81. Then you press calculate 2 equal 8 over 27. Calculate 3 equal, then you get 8 over 81. You see it's quite fast. Huh? Calculate 4 equal, then you get 1 over 81. So we managed to get the probability for each values of x, and now they show the graph. Okay, let's see. The first one 16 over 81, which is here, so true. The second one 32 over 81, which is there. This one 8 over 27, right? So if you want to change it to the same denominator of 81, so you just times 3. So then you get 24 over 81. So where you will see this one is around 24, you see. So this is 25, so 24 is there. Okay, likewise for 8 over 81, you can see here, this one is a little bit below of 10, so that is 8 over 21. And finally, this is 1 over 81. Okay, you can see it there. Okay, so that is how we sketch the graph. Okay, now let's move on. Okay, so we have questions which require you to sketch the graph. And then question again. Okay, now we look at part C also. Part C is where they ask you to find the mean, the variance, and the standard deviation of each binomial distribution. So you see, for a binomial distribution, you can represent it by using this format: x followed by a wave, followed by b means binomial, followed by n. We discussed n before, number of trials or number of repetitions. P is probability of success. We don't put q because when you know p, q is just automatically 1 minus p, so q is not really a very necessary to write in this format. Okay, so now you want to find mean for binomial. It is very easy. Mean for binomial, you just take n multiply with p. Variance for binomial is also very easy. Just take n multiply with p followed by q, npq. Standard deviation, just square root the npq. You know, square root variance is standard deviation. Okay, so the formula is kind of easy. You just need to recognize your npq only. Okay, so let's see example. A sample of 16 families is chosen at random. 16 families. So you keep repeating this process of choosing families. So n is 16. It is found that 20% of the families, 20%, have only one child. So this is binomial. This is two outcomes because have one child or not one child. Not one child can be no child or more than one child, so that's why these are the two outcomes. The success is one child, the failure is not one child. Okay, so probability of success 20%, right? So 0.2. Q is 1 minus 0.2, so 0.8. 0.8. Okay, now what they ask is find the mean. So mean is mu, which is np. So n is 16, p is 0.2. 16 times 0.2, we get 3.2. Variance, sigma square is npq. 16 times 0.2 times 0.8, so we get 2.56. standard deviation sigma. Okay, so it's square roots of NPQ, so square roots of 2.56, so you will get 1.6. Okay, so we just stick to the formula. It seems like this is kind of direct. Okay, so remember the symbol. This one is known as mu, this one is known as sigma square, this one is sigma. So mu represent mean, sigma square represent variance, sigma represents standard deviation. So they are the mathematical symbol. Okay, now let's move on. Okay, now let's see how we solve the problem. Okay, let's see this problem. A study shows that 30% of the youth in a certain district are students of higher institutes of learning. 30% of youths are students of higher institutes of learning. Okay, that means 30% are success. Okay, so there are higher institutes of learning. Maybe they study in college or university. Okay, 30% study in college or university, for example. Okay, so P is 30%, and then Q 0.7, which is 1 minus P, right? And then N, okay, let's see. If a random sample of 10 youths is chosen from the district, so we are doing the survey on 10 youth, so the number of trial is 10. Okay, so we tried it on 10 youth. Calculate the probability that exactly 2 youths are students of higher institutes of learning. Exactly 2. Probability, you know just now the formula, Px equal to, I write again, Px equal to R NCR P power R Q power N minus R. So this is the formula. Px equal to 2 because they say 2 youths. So N is 10, C 2, 0.3 power 2, 0.7, N minus R, 10 minus 2, 10 minus 2. So they want us to find a probability of one value only. So do you need to key in or not, like just now? My suggestion, better key in, because later they ask you to count the probability for more. Okay, so we key in. How to key in again? You key in like this, 10cx times 0.3 power x times 0.7 10 minus x. Okay, so you have to key in this, then press calculate. So 10cx, I key in now, 0.3 power x then multiply 0.7 power 10 minus x, calculate. Okay, so now we put 2 inside, and then we get 0.2335. So you keep everything in your calculator first, don't clear anything, because in part B we still need to use the formula. Okay, part B. So let's go through the formula first. Keep your calculator on. Less than 3 youth are students of higher institutes of learning. Less than 3. So we write like this. Px less than 3. Less than 3 means 0, 1, and 2. So we already know the probability of 2, which is 0.2335. So we calculate, we use the calculator again, no need to key in anymore, the formula is still there. Calculate, then put 1 inside, so we get 0.1211. Then we calculate, put 0 inside, then we get 0.02825. Okay, now we add up. Okay, so we get 0.3829. Okay, so that's the final answer. Okay, let's see the next page. So we have problem solving and normal distribution. I will leave it for next time.